Okay, Laura, let's get to the nitty-gritty of captive marine mammals and birds' most common health issues, pneumonia. There is plenty of research around this topic, but little is known about the most probable causes of these issues.
Welcome to our webinar about the hidden threats for marine mammals lurking in chlorinated systems. So everybody has heard of disinfection byproducts, but what are disinfection byproducts, Mike?
Well, disinfection byproducts, or DBPs, are unintended compounds formed when disinfectants like chlorine or ozone react with organic matter, such as urea, fecal waste, and uneaten food. Chlorine is widely used in facilities to maintain water quality and prevent the spread of pathogens among animals and to personnel. Several factors influence the DBP formation process, such as disinfection dosage, contact time, temperature, pH levels, and most importantly, the amount of organic matter in the system. We strongly believe in the principle, prevention is better than cure. So everything that is removed by filtration cannot form DBPs, and using less disinfection means fewer sources for DBP formation.
So with that in mind, let's dive deeper into chlorination DBPs. DBPs can be divided into three main categories: chloramines, haloacetic acids, and trihalomethanes. For this session, we'll focus on two key groups: trichloramines and trihalomethanes, or THMs. So, trichloramine, also known as nitrogen trichloride, is responsible for the typical chlorine smell. This happens when chlorine reacts with ammonia.
So now you've said something about trichloramines. What about trihalomethanes, Laura?
Mike, don't be so impatient. One of the most well-known THMs is trichloromethane, or chloroform, a compound once used as an anesthetic in the 1850s until the early 20th century. THMs form when 3 out of 4 hydrogen atoms in a molecule are replaced by halogen atoms, such as chlorine or bromide. But we'll come back to this in more detail. Because of water movement and splashing, both trichloramines and THMs are easily released into the air, especially in marine mammal facilities, putting trainers, workers, and the animals themselves at risk through inhalation exposure.
So trihalomethanes, due to their high dermal permeability and volatility, can be absorbed through the skin, inhaled, or taken in through accidental swallowing of water. The potential health risks associated with THM exposure in recreational swimming pools have gained increasing attention. However, detailed studies on the quantified exposure and risk assessment of THMs for marine mammal workers, such as trainers, veterinarians, and volunteers, as well as for the captive marine mammals, remain limited. Let us now explore some documented effects on aquatic animals and humans, highlighting the importance of addressing this crucial issue. There are some statements and conclusions from different sources. As a biologist, Laura, why don't you take this?
Okay, Mike. As I completed university more recently, maybe my memory is better than yours. Let's find out.
Let's see.
Okay, here are some key findings. In recreational pools, dissolved organic carbon mainly comes from swimmers' hair, sunblock lotion, saliva, and urine. But in marine mammal pools, the biggest DBP precursors are uneaten food, for example, fish and squids, urine and feces. Did you know that a single dolphin that eats 7 kilograms of food produces 4.6 liters of urine and 1.4 kilograms of poop every 24 hours? But it's of course dependent on the body weight and size. That's quite a bit when you think about it, right?
You're right. Are there any other variables to consider?
Yes. So if just 5% of food remains uneaten, it can contribute to nearly half of the THM formation in the pool. So it's crucial to remove uneaten food or food particles as fast as possible to ensure it doesn't enter the DBP production cycle. A study on sea lions showed that if only 5% of uneaten food remains in the pool, the food will contribute 46% to the THM formation budget, followed by 34% contributed by feces and 20% by urine. This study states that among the 3 exposure routes of THMs, inhalation poses the highest risk for cancer, followed by dermal absorption and oral ingestion.
So how exactly do these trichloramine compounds form?
Trichloramine production happens when urea and ammonia, commonly found in organic matter, react with chlorine. Even at a neutral pH, acidic conditions on biofilms inside filters can lead to deformation. The reaction process is relatively slow. Therefore, removing these precursors can significantly reduce trichloramine formation.
And is the formation of trihalomethanes very different to the formation of trichloramines?
Well, these form when organic compounds are exposed to UV or sunlight in the presence of free chlorines or bromines in seawater. As the reaction proceeds, the chlorine or bromine radicals hit the molecule and the hydrogen atoms are replaced. As time goes on, there is an increasing chance of trichloromethane being produced. And also in seawater, we get tribromometanes and mixed bromo and chloromethanes. Can you give us a key takeaway, Mike?
Sure, if I understood you correctly, trichloramines are nitrogen-based reactions, while trihalomethanes are carbon-based reactions. Both are reduced with the increased removal of particulate matter. Great. Laura, do you have a good case study to support what we've discussed so far?
Yes, I do. Here is a graph comparing dissolved organic carbon and THM concentrations in different locations. It shows that the concentration of dissolved organic carbon is highest before disinfection. But once chlorine is added, THM levels spike. Therefore, the more precursor material that can be removed, the lower the potential of THM formation.
Do you have any more to show us?
Yes. So on this graph, they compare different precursor sources, so uneaten food, scat and urine in both fresh and seawater. It shows that THM formation in all the precursor sources dramatically increased in the presence of bromine. And on top, in saltwater exhibits, not only chloroform is formed, but also the mixed forms such as bromochloromethanes and bromoform. They clearly showed that the THM formation happens during the water disinfection process, confirming our previous point. The more organics removed, the less potential for THMs to form. And once again, this reinforces our key message. Mike?
Everything that is removed cannot form DBPs, and using less disinfectant means fewer sources for DBP formation.
Okay, so scan the QR code for more information and stay tuned for the next videos. And don't forget to share.
We also have a range of YouTube channels specific to applications of your interest. Scan the QR code for the one that is most relevant to your industry.
Thanks for watching and stay tuned for our next video. Bye!
Bye!